Hello, I'm Ziba Akarcalı, and I will be talking about the paper called A Decision Support Mechanism for LEED Building Design and Construction Transit Stations. My co-authors are Dr. Şehnaz, Cenani, Durmazoğlu, and Professor Dr. Gülen, Çağdaş. The 2019 Global Status Report of International Energy Agency states that the construction industry is responsible for the 39% of the carbon dioxide emissions around the world, which makes the industry one of the most extensive greenhouse gas emission contributors. Organizations such as USGBC, BRE, and DNGB provide green building certifications for the construction projects that apply and fulfill the green building requirement. According to the data obtained from Turkish Green Building Council, ÇEDBİK, there are 5 green building certification systems that are utilized in Turkey since 2007. These are LEED, BREEAM, DNGB, EDGE, and ÇEDBİK certifications, and there are 484 buildings that acquired at least one green building certification. In Turkey, LEED is the most dominant certification system, covering the 84.2% of the certified buildings, with a total of 411 buildings. According to the data obtained from USGBC, there are 897 buildings in total, which is either certified or registered for LEED certification. LEED certifications require multiple disciplines to work and decide together for the most appropriate and feasible credits to apply in the project in order to obtain a LEED certificate. In terms of LEED certification, we have came up with 3 variables that affect the level of certification, which are the cost, the simplicity, and the points of the credits. Decision makers are faced with the problem of balancing the cost, points, and simplicity factors because among the 40+ credits with a wide range of points assigned to each and concerning multiple disciplines in the organization, it is difficult to compare the cost, simplicity, and point factors and reach a conclusion. Literature review shows that several decision support systems are proposed and applied in different approaches for various LEED handbooks, excluding LEED Building Design and Construction Transit Stations, since this handbook is fairly newer than its peers and still under development. Most of the studies are utilizing analytic hierarchy process as a decision support system method, and case studies to test the system. On the other hand, most of the studies conducted on this topic cover existing building certifications rather than new constructions. The purpose of this study is to propose a decision support mechanism for LEED building design and construction transit stations in order to ease the process of presenting alternatives for a final decision and test the proposed analytic hierarchy process design on a metro station in Istanbul, Turkey as a case study. LEED building design and construction transit stations is chosen because of its developmental nature in order to provide a scarce example among its peers if successful. The goal of this study is to obtain alternatives for the lowest cost, collecting the highest LEED points, or choosing the simplest LEED credit requirement. In this study, analytic hierarchy process is utilized as a decision support system, which is a structured technique for organizing and analyzing complex decisions based on mathematics and psychology developed by Thomas L. Satie in the 70s. This process allows ranking alternatives in order to provide a clearer vision for the decision makers. The process diagram study is as follows. First, we need a goal, which is the most efficient LEED building design and construction transit station alternatives for certification achievements. Then identifying the efficiency criteria, which are points, cost, and simplicity. Then identifying the criteria ranking categories. In points, there are 19 categories, for cost it's 6 categories, and for simplicity it's also 6 categories. Then we pairwise compare these ranking categories for each criterion. Then we rank each 44 alternatives in accordance with the LEED Building Design and Construction Transit Stations Handbook, technical specifications of the project and the professional experiences. Later on, the pairwise comparison of the criteria in terms of importance level of each criterion to the decision maker. Then we synthesize the model and obtain a ranked report. And then we ask the question, does the result in the ranked report satisfy the call? If it's yes, then we start selecting the most efficient alternatives for certification achievement. But if it's no, then we differentiate the importance factors for different result outcomes and then again synthesize the model and obtain another ranked report and ask the ultimate question again. There are 414 points available under 60 credits and 9 categories if all the requirements in the handbook are met. For the sake of this study, regional priority category and IN1 innovation credit from innovation category are discarded because of these categories are bonus credits along with the prerequisite credits, since achieving those credits is obligatory for collecting points under each respective category. The remaining 8 categories provide 105 points to compare. The credits under these 8 categories will be called alternatives in the context of AHP. AHP ratings enable rating each criterion for each alternative, which is then used for calculating the priority value for each alternative. The priority values are affected by the criteria ratings and the weights of each criterion. The weights of criteria are calculated by a pairwise comparison matrix. For this study, there are 3 criteria identified: points, cost, and simplicity. Each identified criterion has ranking values, and super decisions calculate priority value for each rank according to the pairwise comparisons of the elements in the respective set. The ranks of the points criterion are given based on the maximum possible achievable point of the LEED Building Design and Construction Transit Stations project checklist, which is 19 points at the EA2 alternative offers. For the comparison of the 20 ranking levels of points criterion, the direct data entry function of super decisions was utilized for each ranking level except rank 0. The numerical value of the level was assigned on the direct data entry window. Since super decisions does not allow 0 as a comparison value, a hypothetic 0.01 value was assigned for rank 0. Cost and simplicity criteria rankings are identified on the basis of the first author's experience on both rail systems and LEED certifications. For the cost criterion categories, each category was pairwise compared on a comparison matrix, and the importance factors of the categories were obtained by assigning the higher price to lower price ratio to the lower price. The ranks of the simplicity criterion were also assigned on the direct data entry window. Each category was assigned a number ranging from 1 to 6. 1, the non-applicable, being the least feasible, and 6, no extra work, being the most feasible simplicity. The case study includes the 8th station, the Mevlana station of the Durmazoğlu metro line. This station has a 3,350 square meter station footprint, 11,000 square meter gross floor area, 6,500 square meter construction site area, 25 meters station depth from the ground level, 3 floors, 100 meters station length. And this station is built with the cut and cover construction method. The selected metro station is studied and analyzed in accordance with LEED Building Design and Construction Transit Stations Handbook and technical specifications of the Durmazoğlu metro line, along with various interviews and ad hoc calculations with the employees of the project. Preliminary analysis showed that the existing design criteria of the metro station can only achieve 35 points of 114 points, which is not enough to be eligible for a LEED certification. The credit analysis showed that 10 irredeemable LEED credits are suitable to be included in the design along with their respective design measures, costs, and points provided. In this table, we can see the additional LEED credits with their respective design measures, costs, and points. There are 10 irredeemable credits that can be included in the project design, which can help the goal of achieving a LEED certification. The ranking diagram of the alternatives as follows. First, we ask the question for an alternative X, that is it achievable by current design? If the answer is yes, we rank points accordingly, assign 0 to the cost, assign no extra work to the simplicity. If the answer is no, we ask the question, is there a possible design measure that can be included in the existing design to achieve points? If the answer is yes, we rank simplicity, points, and cost criteria accordingly. If the answer is no, we assign non-achievable to the simplicity and assign 0 point to the points and cost. According to the ranking diagram, we have ranked the 10 irredeemable criteria, which are as follows in the table. After ranking additional credits and the rest of the available credits in the design, existing design, we synthesize the pairwise comparisons with assigning equal weights to the points, cost, and simplicity criterions. In this context, all the criteria importance levels are equal to each other, and we can see that with the lowest cost and the easiest credits with the highest point values are prioritized for the utilization. Later on, we have synthesized the ranking of the alternatives in which the points have the heaviest weights and cost and simplicity factors has the lowest and equal weights. And another ranking in which point and simplicity factors has the highest and equal weights, while cost factor is the least important factor for the ranking. Now we can see that both tables side to side has some differences in the rankings of the alternatives because of the different weights. LEED is a valuable and one of the most known green building certificates which is widely preferred worldwide. LEED Building Design and Construction Transit Stations is a brand new handbook of LEED which aims to require more appropriate and applicable measures from the transit station constructions. Determining the most efficient way of obtaining a LEED construction is a difficult task because of its multidisciplinary nature and requirement of professional expertise to assess and quote the necessary measurements. In an attempt to facilitate LEED credit assessment process as a result of the literature review on the topic, the analytic hierarchy process method utilized via super decisions was found to be useful. For the AHP, the goal was set as finding the most efficient LEED credit alternatives for achieving a LEED certification. In order to reach this goal, 3 criteria were set: points, cost, and simplicity. In order to test the designed AHP model, a case study was conducted on a metro station in Istanbul, Turkey. All 44 alternatives were ranked accordingly to the LEED Building Design and Construction Transit Stations Handbook and technical specifications of the metro station. Lastly, 3 exemplary priority matrices were obtained from rating for super decisions, each consisting of different criteria weights. The results of the matrices show that, in terms of the existing design criteria of the studied metro station, it is not possible to achieve a LEED certification. Points weight dominant matrix enables LEED certified level with minimum cost, and points and simplicity weight dominant matrix enables LEED silver level with a much higher investment required. The important notes from the study can be summarized as follows. First, the case study shows that the designed AHP ranking model facilitates the decision-making process for LEED certification, but it should not be forgotten that the results obtained in this study are not universally valid. Secondly, the general structure of the model along with points and simplicity criteria would be useful for most cases, but cost criterion categories must be adjusted for each case by professional experts. Thirdly, it must be stated that even though this case study was conducted by a group of academic architects, it would provide better and more precise result if the rankings of the alternatives were conducted by professionals of their subjects. And lastly, the designed AHP ranking model is convenient for the multidisciplinary decision process for LEED certification, which is strongly suggested for decreasing the margin of error in the assessment, assignment, and application of the measures and keeping the investment costs to a minimum. Thank you.